Okay, so solutions in our society. Solutions are all around us and they affect our lives in many different ways. So we have developed many technologies to meet the personal and industrial needs of humans. So for example, we have hair products, breathalyzer testers, and tests that monitor our drinking water. In using solutions in our lives, care must be taken to ensure responsible use. So we have a responsible care program. It was set up in 1985 to ensure that companies deal with chemicals they are using in a safe and appropriate manner. So using solutions can be intended or unintended consequences for humans and in the environment. Toxins released into the environment are taken in by organisms, and these can have immediate toxic effects. So, for example, H2S or sour gas can cause loss of consciousness at 700 parts per million. Sometimes the lower levels of the food chain are unaffected by the toxins since the levels are not that high, but the toxins are then passed along into the upper levels of the food chain. So, and organisms at the top of the food chains, like humans, can end up with toxic levels of these chemicals. So, for example, mercury, lead, arsenic, PCBs, and DDT. So, the biomagnification or bioaccumulation is the increase of the concentration in toxins as you move up the food chain. Okay? So, for example, here we have, these little concentrations that are in each of these little organisms. Then as you move into the fish get larger ones, seals get larger ones, polar bears end up getting the most of this toxic environment or this toxic chemicals or contaminants. Okay, so we must assess the risks and the benefits for using technologies that contain certain substances. For example, heavy metals released from material or mineral processing power plants like mercury and arsenic. Okay, now we need to talk about some ways of expressing concentration. Concentration is the amount of solute relative to the amount of solvent. So to dilute something means low solute and high solvent. But when something is concentrated, that means you have a high solvent for a high solute for a low amount of solvent. Concentration can be expressed in a variety of ways. So for example, we have parts per million, parts per billion, parts per trillion, or percent mass, or percent volume, moles per liter, millimoles per liter, milligrams per deciliter, and we have percent. Okay? So these expressions can be seen on many products that we use in our daily lives and in industry. So for example, vinegar is 5% acetic acid per volume, toothpaste is 0.23% mass of sodium fluoride, blood cholesterol levels, okay, and then a breathalyzer gives you a percent of grams per alcohol and 100 milliliters of blood, okay. So, molar concentration, if we're looking to calculate that is molarity, so the number of moles of solute per liter of solvent. So concentration is number of moles per volume of your solvent. Okay, so the number, and we know that the number of moles is the mass divided by the molar mass, where C is the concentration in moles per liter, N is the number of moles in moles, and V is the number of volumes in liters, mass in grams, and molar mass in grams per mole. Now, in the next video, we're going to look at some examples of calculating molar concentration.